Welcome to a lesson with Dr. Powell. Let's suppose that we have a velocity function and it's representing up and down movement with respect to time. So in reality, the object itself is going up and down, even though our graph kind of spread out. That's because we're just looking at what's happening at different values of time and just kind of looking at it. So not particularly this axis is feet per second, and let's also suppose that this point is at 2, so that's 1 2 3 4 5 6, so it's 6,2. Question is, let's suppose that our position is we start at 1 foot above the ground, maybe, or maybe not. Maybe there's a hole, so at ground, and then we're going either down or up, through the hole or whatever. But let's suppose that we start at 1, at a height of 1 above. And so that's where we're starting. The question is, after t seconds, where are we located? Looking at this velocity function. So we think, okay, well, first we're going to, now let's take this right here as a definition for the velocity function, just as we begin going from this point to this point. So we can think, all right, this is going to be sine of, we're going to look for the area under the curve right here of this as we go from 0 to 2. Now we need to find an antiderivative for this. Now notice that if we're taking a derivative of something with pi halves t plugged in, when we take a derivative, we'd be multiplying by pi halves. Notice that we don't see a pi halves here at all. So it must have canceled. So something must have canceled out when we multiply by pi halves. So originally in our antiderivative, we probably had 2 over pi, just the reciprocal of that multiplied on. And then the antiderivative of sine is just negative cosine. So let's see, let's double check to make sure that's right by taking a derivative. The derivative of cosine is negative sine, both the negative becomes positive of the same thing, but you multiply by halves, it cancels 2 over pi, yes. So that's an antiderivative. Then we go from 0 to 2. Okay, so when we plug in 2, we have cosine of pi, which is negative, so we end up getting negative 2 over pi. Oh, well, but then times the negative, we have plus. Okay, so we get plus 2 over pi, because we have negative 1 times negative, so positive 2 over pi. We plug in 0. Cosine of 0 is just positive 1. So we end up getting minus this negative, which becomes positive because we're subtracting what we have when we plug in a 0, and then that interacts with that negative, becomes a plus. So we have a plus 2 over pi. So it looks like we end up, we just simply end up getting 4 over pi for this first part. So it looks like we've gone up. We started at 1 foot, and looks like we've gone up 4 over pi. So our object has started at 1 and went up 4 over pi. Next, it looks like it's going to drop. This is a semicircle, so suppose this is a radius of 1. How much does it drop? Well, the area here should be pi halves, because you have pi times 1 squared for the full thing. So pi for the full circle, but it's half of that. So it looks like we now have dropped pi halves. So we first raised 4 over pi, and now we're dropping by pi halves. Now what happens over here? Well, assuming this is a straight line, this goes 2, 2, slope of 1. It's just 1/2 of this square here. The square is 4, so it's 1/2 that, so it's 2. An area of 2 right here. Okay, so it looks like we've added 2. So in the end, this is the position in feet where we land. And we can know that just by looking at the graph of the velocity itself. Thanks for watching.